All right, so in the last video, we introduced the idea of an inverse function. And I told you that we're going to work with inverse functions for a while, off and on, off and on, off and on, over really most of the rest of the semester. So in this video, our second video on inverse functions, we're going to talk about how to find the equations for an inverse function. But we are going to start in this video focusing on just very basic types of equations. And then over the course of the semester, we'll move on to more involved and more complicated types of equations. So that's the plan here for this video. In fact, for our learning objectives, that is our only learning objective. Simply find the equation of an inverse function. And as I said, the equations we're going to work with today in this video are relatively basic types of equations. There's not going to be a lot of fanciness. Notice you'll see this is a part one. The video for the last lesson of this particular week's material is on the same topic, but we'll look at a slightly more advanced type of function. Okay. One side note, just so you know, when we ask you to find the equation of a function's inverse, we're not going to do any sort of trick questions in that we're not going to give you a function that doesn't, that its inverse is not also a function. Okay. So it'll always be the case that we will give you a function and its inverse will also be a function whenever we're asking you to try to find its equation. All right, so with all that as a background, let's get started. The first thing to this is one of the things that we talked about in the last video. So this first point is just a reminder from last video. We said in the last video that one of the implications of the way inverse functions work is that inverse functions switch the domain and the range from the original function when compared to the original function. And in other words, and maybe if you want to jot a little note in the margin to clarify that statement, in other words, whatever the domain is of the original function, that will be the inverse's range. And whatever the range is of the original function, that will be the inverse's domain. So the domain and the range literally switch. They don't change at all. Whatever they were, they still are. They just switch which one is which. So if the domain was all real numbers for the original function, then for the inverse, the range will be all real numbers. Okay, so that's the idea. And the other thing to keep in mind, we've talked about many times, domain is represented with the x value, and range is represented with a y value. So that key idea from our last video is really what opens the door for us to be able to find a function's inverse. So the idea goes like this. We're going to jump right into an example. In fact, this video is only going to have 2 examples. It'll be a relatively short video. And as we work through this example, at the same time, I'm going to outline some steps that we'll use for finding the inverse. Okay, so the directions, I'm not going to bother to write it. You can pause the video if you want to write them down. But the directions for a problem like this would just simply say, find the equation of the inverse. Find the equation of the inverse. All right, so if we're going to find the equation of the inverse, first we have to be given an equation of a function. So let's suppose I've got this function right here. And we're going to find the equation of the inverse to that function. Well, the first thing that we need to do, and this is something that you can just think about, you can just do this cognitively. You don't necessarily have to write this down, but for the purpose of our notes, I will write this down so you can see it. The first thing you have to do is just remember from our discussion on functions that f of x is the same as a y. F of x is the same as a y. So we want to, whether we do it in writing or just mentally, we want to make sure that we think about the f of x as a y. We want the f of x to be a y. So that's going to be my first step, is turn the f of x into a y. Everything else will stay the same. So I still have an equal sign, I still have a 2x, I still have a minus 10. That all stays the same. Now, the reason why that's important for us to do is because step 2 takes advantage of this property that inverse functions have. The nature of an inverse function is such that the domain and the range are going to switch. In other words, the x's and the y's are going to switch. So that is literally what we will do. We will switch the x's and the y's. Now in this particular problem, that's not too hard because there's only one of each. So where the y was, or I'm going to put the y where the x was, and I'm going to put the x where the y was. So the x that was here is going to end up over here. The y that was there is going to end up over here. Everything else in the equation stays the same. So I still have an equal sign, I still have a 2, I still have a minus 10. Everything else stays the same. I just switched the x and the y. Now, quite literally, this equation right here does represent the inverse function. As soon as we switch the x and the y, as soon as we switch the domain and the range, technically this is a representation of the inverse. And so there's a very real sense in which we have accomplished the task. We have an equation, right? There's an equal sign. We have an equation, and that is the equation for the inverse. That is it. As soon as we switch the x and the y, we have the inverse. But you know, because you've been around math long enough, that mathematicians like to write their answers in a particular sort of format that's standardized. And so that becomes the last part of our procedure. The first thing we want to do is switch this equation into function form. And remember, function form means the y is by itself. So the next thing I want to do is solve for y. Get y by itself. So on this problem, if I'm going to solve for y, the first thing I'll need to do is move this 10 over. So I'm going to add 10 to both sides. That gives me an x plus 10 over here. And then I still have the equal sign, and I still have the 2y over there. And then the next thing I will need to do, if I'm going to divide both sides, or I'm going to need to divide both sides by 2. Now remember, technically I'm dividing the whole side by 2, but because there's a plus sign, that will distribute. So I'm going to get an x divided by 2, and I'm going to get a 10 divided by 2 when I distribute that division. So x divided by 2, well, that just becomes a 1/2 x. 10 divided by 2, that becomes a 5. And then the 2's will cancel over here, and we'll just have the y. So now the y is by itself. And then the last thing we want to do is rewrite it in function form. I'm going to write this in a slightly different way. We are going to rewrite it in function form, but I'm going to write that a slightly different way. So I'm going to leave that blank for just a second, and let's actually do this. So in function notation, I'm going to rewrite it using function notation. I think I said that wrong a second ago. I'm going to rewrite it using function notation is what I'm going to do. So remember, in function notation, typically speaking, we put the function symbol on the left-hand side, and then we've got the rest of our equation. So I'm going to take this y, and I'm going to switch the y into function notation. That's what I'm going to do right now. Switch the y into function notation. So I'm still going to have an equal sign. I'm still going to have a 1/2 x plus 5. None of that's going to change, but I'm going to switch the y into function notation. Now, if you think back to the last video where we introduced inverse functions, I mentioned what we're about to do right now very, very briefly. So maybe this time I'll go a little bit slower, make sure you're comfortable with this. When we name an inverse function, we want people to know that this is not just any random function. So I don't want to just slap a random name right here. Remember the f of x, it's the same as y, but the f of x also acts like a name. So I don't want to just give this a random name. I want to connect it back to f of x somehow so that people know this thing is connected to this thing. But I already have an f of x, so I can't just call this f of x. That would get confusing to have two functions that are both called f of x. So what we do, I think I said in the last video, I think I used the analogy in the last video, this is like the mathematics equivalent of naming your child after yourself. If I were to name my son after myself, I would give him the exact same name, but then at the end, I would put a junior. And that shows everybody that he is named after me. So that's kind of what we do with inverse functions. We start by giving it the exact same name. That's where we begin. But we can't leave it identical because then people get confused. Which function f are you talking about? So I'm going to give it like the math version of a junior is what I'm going to do. And what I said in the video yesterday is the way we do that is by giving it a little -1 exponent. A little -1 exponent. And so that becomes our last step, is the y becomes an f of x with a -1 exponent. F of x with a -1 exponent. And remember what that symbol means. The -1 tells me it's an inverse, and specifically it's the inverse of function f. The name connects it back to the original function. And so there we go. There is our inverse. So these are the 4 steps that we go through to get to that function. Now, as a side note, we also talked about yesterday that what functions do is they cancel things out. So we ought to be able to test to make sure that this is actually something that acts like an inverse. So if I take my original function, which was this, and I take the thing that I believe is the inverse, which is this, then I should be able to plug a number into the original function. And for the purposes of our test right here, I'm not really proving that it's in the inverse, but I'm just kind of making sure that, yeah, things seem to work the way they should work. So I'm just going to pick any random number. It doesn't really matter what number. Let's go with the number 6. I don't know. Plug in the number 6. So if I plug in the number 6, whoops, minus 10, I'm going to get 2 times 6, which is 12. 12 minus 10 is 2. So it turns out that f of 6 is equal to 2. F of 6 is equal to 2. So remember what we said in the video yesterday. Now if I take the inverse and I plug in 2, what should happen is I should end up with the original number back. Okay, so the original number was a 6. So when I plug 2 into the inverse, it should undo all the math that I just did right here, and it should spit back out the original number of 6. So let's see if it does that. 1/2 times 2 is 1. 1 plus 5 is 6. And so, yeah, the answer that I got here, it matches the original number that I plugged in over here. So that's a good indicator that we found the correct equation, that actually is the inverse. Okay. Now, technically speaking, if you go on to more advanced math classes, you'll find that this isn't actually a proof that it's the inverse, and there is a way to prove that, but we're not going to go into that in our class. This just shows us that, yeah, there's a pretty good chance that that's actually the inverse. Okay. So there's our first example. I did say I was going to try and do 2 examples. There's our first one. Most of the problems that you'll do in the homework associated with this video work with linear equations. So most of the problems that you do will be very similar to this. But I do want to introduce a situation where that's slightly different, but still a relatively straightforward, a relatively easy type of equation to work with. So let's say that instead of having a linear function, I guess let's make this, well, we can call it function f. It's going to be a different function than this one, but normally I would call it g or something, but I already wrote it, so I'll just stick with it. It doesn't matter what its name is. But let's say that this function is a very simple, basic sort of cubic function. Okay, so let's say that it's like x cubed, I don't know, plus 7 or something like that. All right, just a very basic polynomial function. Now, if we were to graph this polynomial function and do the horizontal line test, it would pass. This thing does have an inverse. And like I said at the beginning of this video, we will never ask you to find the equation of a function unless the inverse is also a function. And in this case, it is true that the inverse of this thing is also a function. So we can go through our process. Here's our 4 steps. We're just going to work right through those 4 steps. So whether you write it out or whether you just do it in your head, you need to think of this f of x as being a y. That's where we want to start. Think of the f of x as being a y because they're the same thing. Now, we're going to switch the x's and the y's. So the y that I have here is going to become an x, and the x that I have here is going to become a y. And then I want to work to get y by itself. That's our 3rd step, solve for y. So to get y by itself, well, it begins simply enough. I'm going to subtract 7 from both sides. That's exactly the same as kind of what we had before. But now I get here, and the 3 isn't being multiplied by y, it's an exponent. So remember, if over here, I divided because division is what cancels out multiplication. I need to get rid of that 2. The 2 is being multiplied, so to cancel it out, I use division. Division is the inverse of multiplication. But here, I'm not multiplying. Here I have an exponent. So thinking back, how do I get rid of exponents again? Well, the way that we did that was we used radicals. And typically, we're working with things that are squared, so we typically use square roots. But this isn't squared, it's cubed. So I can't use a square root, I need a cubed root. I need a cubed root. And so our rule for algebra is we can do whatever we want. We just have to make sure we do it to both sides. So again, I'm doing it to the whole side now. But radicals are different than division. With a division problem, like we had here, division can distribute across the plus sign. And so I end up dividing both of those things by 2 because division distributes. But radicals do not distribute across plus and minus signs. So I cannot simplify this at all. My answer just stays the cubed root of x minus 7. Now over here, the cubed root and the cube cancel each other out, and I'm left with just the y. So now I have y all by itself. I've written this in now function form. So I'm going to turn the y back into function notation. I use the same letter, so I'm going to use f, but I'm going to give it a -1 exponent, and then just write the rest of the equation, and that becomes my answer. All right, so these are the types of problems that you'll be doing in the first homework assignment associated with finding the equations of a function's inverse. All right, thanks for watching. Have a good one.